This is 5.9 linear combination, and this is totally different than what, well, the beginning of this is totally different than what we've been working with. So let's look at this. Okay, so the first thing I want you to look at is this linear combination formula here. On the left side, if you were to look at this graphically, this would be like an amplitude plus an amplitude is equal to an amplitude with a shift. So remember, this is a shift right here. Okay, so what is so different about this is you're totally using these equations right here. This is where it stems from. Now, if you're looking at this, this kind of looks like Pythagorean theorem. And then, of course, we're going to have to either use, well, we're going to have to use both. We're going to have to use a cosine and we're going to have to use a sine. So this is the most important thing that we're going to be looking at right here. Okay, so how are we going to use this? It says transform the single cosine expression. Now what I always look at is I want my cosine to be first and my sine to be second. So I'm looking at this side right here. So cosine is first, sine is second. From this information, you can pull the A value and you can pull a B value. That should be a B. You can pull your A and B value. And you're going to be using A and B up here in your sine and cosine. So your A is your coefficient in front of cosine, which is root 3. Your B is your coefficient in front of sine, which is 1 in this case. Okay, after you find your A and B, from there you can get your C value. Your C value is basically your Pythagorean over here. So I'm going to plug it into my square root of A squared. So that's going to be A squared here plus B squared. That would be plus B squared. So my C value is going to be 2. Okay, after I find my A, B, and C, I can go ahead and find my cosine value and my sine value. Okay, so cosine, it says cosine of now D, because my whole goal is to get this right side. Okay, that's the goal. Okay, so cosine of D is now going to be A over C, so A over C is going to be root 3 over 2. Okay, sine of D is going to be B over C, so that would be 1 over 2. All right, so we need to find out what this triangle is. We're looking for the value of D. Okay, so the value of D, if you notice, both of these are positive, so let's go ahead and draw this in the positive quadrant. So this would be positive. Cosine is going to be root 3 over 2. Sine is going to be 1 over 2. So we need to know this angle right here. And it looks like that angle is going to be 30 degrees. I'm going to say, therefore, the angle x is equal to 30 degrees. Or we should say pi over 6. Okay, so now we know pi over 6, or the angle, that is going to be D. Okay, now we can fill it into that last bit of information, which is the right side up here. So we know C, and now we know D. So, therefore, our C, I'm going to write this down. C, it says cosine of parenthesis x minus D. So our C value is 2. We know cosine. We know it's an x. And our D value is pi over 6. And we finished our goal. This is our final answer. So it's a roundabout way of getting to there. Okay, let's try another one. Okay, if you remember, I said that I always rewrite it so that my cosine is first. You don't have to do that. So this is negative cosine of 5x plus a sine of 5x. It does not matter that we have a 5 in that value because you're always looking at your coefficient. So my coefficient for A is a negative 1, and my coefficient for B is 1. Therefore, for C, I'm going to do the square root of negative 1 squared and 1 squared. Therefore, C is the square root of 2. So I have A, B, and C. I now need to go ahead and find D. So I'm going to set up a triangle where my A is 1, my B is 1, and my C is root 2. Okay, so let's go ahead and find cosine of D. Remember, that's A over C, so that's going to be negative 1 over root 2. My sine of D is B over C, so that's 1 over root 2. Looks like we might have a 45-degree triangle here if I'm looking at everything correctly. Okay, cosine needs to be negative. Sine needs to be positive. So it looks like if cosine is negative and sine is positive, it looks like we might be in our second quadrant here. So cosine is adjacent over hypotenuse, and sine is opposite over hypotenuse, and this has to be negative. So it looks like this is a 45-degree triangle. Okay? So what gave us this angle? Remember, we have to worry about what gave us this. So it looks like D might be 3 pi over 4. Okay? So I'm going to write down my formula, and it's C times cosine, parenthesis, x minus D. So our C value was root 2. Then we have cosine, our x minus D value, which is 3 pi over 4. And that is our final answer. Okay, let's try one more. Okay, on this, it looks like they're giving us a little bit more information. Let's see, our cosine is over here on the right side, so they flip-flopped them, and then it gives us more information. Okay, so let's go ahead and do what we've done so far, find our D value, and see what we need to do with this. So our A value is from our cosine, so A value is 1. Our B value comes from sine, so our B value is negative 3. Plug that into Pythagorean, and our C value is going to be 2. Okay, let's go ahead and find cosine of D. Cosine is going to be 1 over 2. Our sine of D is going to be negative root 3 over 2. All right, finding our triangle where cosine is positive and sine is negative. Looks like it might be over here in the fourth quadrant. So cosine is adjacent over hypotenuse, and sine is negative root 3 over hypotenuse. So this angle right here, D, is going to be negative 60 degrees or negative pi over 3. Looks like they're saying, I want, if y'all are noticing anything, I want answers between 0 and 2 pi. This means that I want general solutions. And I know y'all are super duper excited about that. This means general solutions. Okay, so I need to go ahead and write my answer for C cosine x minus D. So my C is 2. I've got my cosine, and x minus, well, it's going to be a plus pi over 3. But now I know what it's equal to, and it's equal to root 3. That's the only difference with this one. Okay, so since I know that I'm looking for general solutions because of this right here, I can go ahead and divide by 2. So I've got cosine of x plus pi over 3. That's equal to root 3 over 2. I can move my cosine over. So I've got x plus pi over 3 equals arc cosine of root 3 over 2. Go ahead and find what your angles are for root 3 over 2. So that's going to be in the positive angle adjacent over hypotenuse, and this is 1. So my principal value is going to be 30 degrees, so that's going to be pi over 6. Okay, so my first equation is going to be x plus pi over 3, and that's going to be pi over 6 plus 2 pi n. Remember cosine? Where cosine is positive, it's also going to be down here in the fourth quadrant. So if you would like to, you can do the negative version of that, which I always think is the easiest. So I'm going to say pi over 3 is equal to pi over 6 plus 2 pi n. When you solve my first equation, you get x equals Finding a common denominator gives you negative pi over 12 plus pi n. Solving your second equation gives you negative pi over 4 plus pi n. Okay, remember you always want to find answers, and this says between 0 and 2 pi. So, let's see. I'm going to get 3 pi over 4, 7 pi over 4. I'm going to get 11 pi over 12, and 23 pi over 12. And that's going to give me all my answers. Okay.